Thank you so much for the introduction, and thank you ASM for inviting me to give this talk at FAScinate 2022. Did you know that nearly half the human population live along coastlines? At the moment, 3 billion people live within 200 kilometers of the coastline. The tendency of humans to migrate there is an age-old phenomenon. The weather in coastal areas is frequently nice, and the sea provides economic access and food supply. Many people find this attractive and move there, giving rise to what we call coastal urbanization. To cater for coastal urbanization, we are seeing more and more extensive developments along our shorelines. In fact, this is so extensive that a new term was recently created to refer to this phenomenon. We call this ocean sprawl. In some places, we have completely maximized the existing coastlines, and we are now reclaiming new land through what we call coastal reclamation. In others, we have even moved beyond developing on coastlines and have gone on to build whole islands like the one you see in the picture on your right. Humans are indeed sprawling into the ocean, and this threatens our precious coastal and marine ecosystems. But the rise in human population and urbanization aren't the only threats that our shorelines are facing. I want you to add the climate emergency into the picture. Climate change, which is caused by us burning fossil fuels and emitting greenhouse gases, is affecting every country on the planet. Climate change causes the Earth's ice caps to melt, and that in turn causes sea levels to rise. It changes the frequency and intensity of storms, increases precipitation and floods, and causes coastal erosions on our coastlines. Because of all these threats, we are seeing lots and lots more scenes like this. Very large coastal defense schemes designed to protect people and property from rising seas, harsh waves, floodings, and coastal erosion, not just in Malaysia, but globally. These hard-engineered structures, like seawalls, breakwaters, and rock revetments, are usually made from concrete or mined granite rocks. They're excellent in playing their engineered function of protecting people and property. However, as we line our coastlines with these structures, we are at the same time replacing our physically complex coastal ecosystems. Our rocky shores, mangroves, seagrass beds, and coral reefs, we're replacing them with hard-engineered concrete structures that lack the physical complexity. Take a look at the picture on your left. Those are the kinds of textures you would normally find on a natural rocky shore. There are pits, crevices, grooves, tidal pools, and overhangs, and you can see there are so many kinds of marine life on it. They use this complexity to hide from predators, escape from the heat, and enjoy the water-retaining environments. Now compare this to the picture on your right. That is the kind of texture you would normally find on a seawall. Smooth, no nooks or crannies. The most you find living on these structures are barnacles and some hardy species of algae. Why? Because they are dry. Not very good for marine life, as you can guess. It's very hot because there's no shade and so very exposed to predators. As the human population continues to increase, there is high chance we will continue to build grey structures like this, and this will replace natural complex ecosystems. If that happens, where does nature go? Can nature exist on human-dominated coastlines? Now, I live in Penang. I was born, bred, and spent most of my life here, and I've seen this happen firsthand. The state has reclaimed most of the east coast of the island and many parts of the coastlines on the mainland. And these are the exact questions I asked myself before embarking on this quest to find ways to balance development and conservation. As I delved into literature, I quickly realized that achieving that balance was not my quest alone, but something governments all over the world were starting to do. At that time, the UN Sustainable Development Goals had just been announced in Rio de Janeiro. The UN SDGs call for action by all countries, whether poor, rich, or middle income, to promote prosperity while protecting the planet now and into the future. And this is all based on the notion, if man can destroy the planet, man can also heal the planet. At the center of the UN SDGs are what we call nature-based solutions, and they are defined as a suite of actions or policies that harness the power of nature to address societal challenges, simultaneously providing human well-being and biodiversity benefits. In short, nature-based solutions uses the power of nature to protect nature. In coastal and marine environments, several ecosystems can be used as nature-based solutions. For example, mangroves. In terms of coastline protection, this natural ecosystem that exists between land and sea can solve coastal erosion by using its extensive web of roots to hold soil together. By having just 100 meters of mangrove forests in front of the coastlines, they can absorb up to 66% of wave energy that come from the sea, hence protecting the people and property behind it. What is more impressive is mangroves can move together with sea level rise. As sea level rises, the mangroves can migrate landward, given there is enough space for them to do so. I bet you seawalls and breakwaters cannot do that. Mangroves can also play an important role in mitigating climate change. The trees and soil absorb atmospheric carbon dioxide and lock it away for millennia. It supports the livelihoods of local communities, sometimes including those of the indigenous people, by providing fishes, crabs, shellfish, and even firewood and medicinal products. And of course, they maintain biodiversity through providing different types of physical complexities that can be found in the structure of their roots, or the texture of their barks, or even the canopies. But mangroves aren't the only coastal or marine ecosystems that can be harnessed for its power to protect. Seagrass beds can dissipate 30% of wave energy over 39 meters and combat sea level rise. They can prevent erosion by accreting soil and absorbing greenhouse gases. Oyster reefs can reduce the energy of high-power waves by at least 76% and potentially filter and clean pollutants out of thousands of gallons of water in a day. Coral reefs, on the other hand, can absorb a whopping average of 97% of wave energy. That's nearly all of it. And we all know there's all sorts of colorful and wonderful creatures that are associated with coral reefs, right? So, basically, natural coastal and marine ecosystems can perform the task of your seawall or breakwater, but with so many advantages. And they are much cheaper to restore than building concrete coastal defense structures. But what if we cannot put entirely natural ecosystems on our shorelines? It is safe to say in some places we can't, because the soil isn't suitable to plant a mangrove, or the water is too salty, or the waves are too harsh for seagrass restoration. Well, we can try to design structures that mimic nature and put these complexities onto the seawall. The science is called ecological engineering, and this is defined as the design of sustainable ecosystems that integrate human society with its natural environment for the benefit of both. Now, even if you've never heard of the term, I'm sure you're well aware of the actual concept. Many of us enjoy green spaces like parks and forests and even green walls like this. And we all recognize that all green spaces are vital for our well-being. And of course, they are vital for wildlife as well. These green spaces are important habitat and corridors that allow wildlife to travel in safety. But how do we do this in the sea? Let's take a look at our coastal defense structure again. How can we improve this environment to make it better for marine life? This is an area where my colleagues and I, and people all over the world, are actively researching and designing novel ways of enhancing the life on these artificial environments. There are even companies cropping up that design products that help do this as well. So, depending what city councils will allow us to do, we can actually drill the pits and crevices onto the seawalls to create complexity and the habitat for marine life. We can go to one of these companies and buy artificial rock pools and bolt them onto the seawalls. These artificial rock pools will become habitats that retain water when the tide is out and holds enough moisture for algae to grow on the dry surfaces of the seawalls. And once the algae starts to grow, this will attract all sorts of marine fauna to find food and shelter, to breed, or to hide from predators. In Malaysia, my team and I attached some of these artificial rock pools on the breakwater in Straits Ski Marina, Penang. We monitored them for a year using GoPro cameras set to take photos every 2 seconds. And after sifting through literally thousands of photos, we found some very interesting fishes using our pools. There were economically important fishes like snappers. There were even reef fishes using the pools, like the red-tailed butterfly fish and the coral demoiselle. We also observed octopuses and 2 different kinds of oysters using our pools. The oyster species that were found outside the pool was one species and on the inside was another. So one habitat enhancement encouraged colonization of 2 different species of oysters and many other fishes. Alternatively, we could speak to scientists to design bespoke habitat panels to promote native biodiversity on the seawalls. Here, we deployed such habitat panels on the seawall in Penang Port. These panels were designed to mimic the undulations on natural rocks. And what they did was they provided suitable habitat for Asian green-lipped mussels, sea urchins, and native oysters on this seawall. The presence of filter feeders like mussels and oysters are especially crucial for port and marina settings because they can clean and filter out harmful chemicals from these polluted environments. Besides that, the oysters and the mussels that grow on them create what we call a biological crust. And this is beneficial because what the biological crust does is it adds stability to the habitat enhancement and offsets some of the carbon footprint from the concrete industry. Generally, for every kilogram of biological crust, that calcium carbonate layer that is created by the marine organisms, we can offset 120 grams of carbon dioxide. So, think about the port infrastructure or that city waterfront as an active carbon sink. That is the great advantage of this technology. It potentially turns a development into a habitat, albeit an artificial one. In terms of size, these habitat panels can even be designed as large fascias that front seawalls with site-specific complexities. And depending on the kind of complexity added, you will encourage different sorts of marine life to use it. What if we were not allowed to work on the seawall itself? We could work on the rock revetments in front of the seawalls. We can create or drill pits and crevices, artificial rock pools directly onto the rocks themselves. In the picture in the middle, you can see my student Jean counting how many marine life are using these pools. In the picture on the right, you can see what the inside of the pools can look like. And those are not stones, yeah? Those are slipper oysters, one mounting on top of another. Now look also at the emergent surfaces around the pool. Do you see any oysters there? No, they are only barnacles, which are really hardy species. And these guys can survive on Mars. No, I'm just kidding. But on a more serious note, most coastal organisms, especially the special ones like oysters, they need spaces where water is retained and shaded areas to thrive. And by adding these pools, we are creating that very space for them. We drill caught these pools in several other granite rock revetments in Penang, and we compared them to the biodiversity of tidal pools in natural rocky shores. And we found that many species that occurred in natural rock pools could also be found in our drill-caught rock pools. So what the drill-caught rock pools did was effectively mimic natural rock pools, making the granite rock revetments, the biodiversity on them, similar to a natural rocky shore to some extent. I like to refer to my drill-caught rock pools as oases in the desert. You could be walking on the rock revetments for minutes on end without substantial signs of life. But when you reach one of these pools, it's just teeming with life. There are banded anemones in there, shrimps, green algae with eggs of marine snails on them, oxygen bubbles where the algae are, and many, many oysters. You can see just what a simple act of drilling can do for biodiversity on a barren rock revetment. If drilling wasn't an option, we could replace this granite rock on the revetments with large habitat enhancement units like the ones you see here. Again, what these do is that they add habitat features that are largely absent on the shorelines. By doing so, we are increasing physical complexity. And if you increase physical complexity, you will increase diversity of life. In my lab, we're even coming up with eco-friendly concrete that's actually beneficial for marine life and has a lower carbon footprint to make these habitat enhancement units. We are really thankful to all the international and national funding agencies, property development companies, my university, Universiti Sains Malaysia, students, and my collaborators from all over the world that have supported us thus far. Indeed, eco-engineering can help humans heal our coastlines. They help us address many of the goals within the UN SDGs, which are set to protect the planet and everything in it. Through preserving nature in human-dominated environments, ecological engineering addresses Goal 11, which is sustainable cities and communities. Through their potential in absorbing carbon dioxide, ecological engineering answers Goal 13, which is climate action. It answers Goal 14, life below water, by protecting marine and coastal biodiversity. And by answering all these goals, we are indirectly answering Goal 3, which is good health and well-being. But can we eco-engineer a situation like this? I'm sure many of you recognize this as the Palm Islands in Dubai. It is the largest artificial island in the world. It has a very large footprint, and you can imagine that whatever used to be underneath these islands as they were built, be it rock, sand, corals, or seagrass, that's long gone now. Clearly, this is a very extreme example, but not a unique one. There are many artificial islands like this, particularly in Asia and the Middle East. This is a cause for major concern, but not something we can hide from. While I am personally against this sort of large-scale developments from an environmental point of view, I'm also aware that within the short time span I'm speaking to you, probably another 4,000 people have been added to the face of the earth. Development is inevitable, but what can we do about it? The first thing we can do is to avoid building in what I'm referring to as the green and the blue spaces. The green refers to the natural environments on land, and the blue refers to those in the sea. These are spaces that have never been developed before. We need to do everything in our might to make sure these spaces are protected. They are precious. No amount of eco-engineering can give you back that 500-year-old coral reef or that virgin rainforest if you develop on it. Now, if development must happen, we need to actively encourage that this happens in the brown and the grey. The brown refers to spaces that have been developed before but no longer serve their functions, and the grey refers to urban landscapes. Now, these are spaces that have already been degraded by humans. It is in the brown and the greys that gets us the wins. We call this win-win ecology. That's the science, making space for nature in human-dominated environments. Now, if we look at it from our own perspective, we're going to develop anyway, so we're going to win no matter what in the short term. But if we look at it from the environmental perspective, this is where the wins are, in the brown and the grey. Nature will definitely lose out if we develop in the green and the blue. Humans have made this planet an unhealthy place to live in. 7.9 billion of us are in one way or another exploiting and destroying nature on unprecedented scales. Yes, we could sit and mope on this fact, wring our hands in dismay that little can be done about the problem. But I suggest we do something else. I encourage you to shift your perspective and view this as we are 7.9 billion people strong. And if each of us takes the initiative to restore, protect, and fund nature, we can heal this planet. I encourage us to join hands and actively consider how we can make space for nature in this human-dominated environment. If not, all we are going to leave for our future generations is a lot of brown and a lot of grey. Thank you.